kind of has a Zecharia Sitchin view of the whole thing. That is, that he believes that it's called Nibiru, that the Sumerians talked about it, that Zecharia Sitchin's translations of the Sumerian texts are more or less accurate. He differs from Zecharia Sitchin in that he thinks it's going to be here, you know, depending on when you ask him, and just after 2012, 2013, somewhere in the near future. So that's kind of where he's at from it. With it also, he differs in Sitchin in that he thinks it is a binary star system, not a planet. So he thinks it's a brown or red dwarf star. So I'm just going to first talk about that issue with Sitchin. A lot of people believe in Nibiru or some version of that. It's really important that you know that the entire thing is, as far as Sitchin goes, we now know that the guy didn't even know the basics of Sumerian art, let alone the language. Of course, Michael Heiser in his excellent website, sitchiniswrong.com, goes through this much more meticulously than I'm about to here, but just a few things on it. The main thing is from this, what they call a cylinder seal, which is something that, like a Sumerian carving, and it's got a picture of what looks like, what Sitchin says is the sun and a bunch of planets around it. He essentially says that the Sumerians therefore knew that there were more planets than there actually are, one of which is Nibiru. Now, this thing is refuted pretty simply, and Heiser goes through it on his site. The Sumerians, like, never would draw the sun, like the thing in the middle there that he says is the sun, i.e. the solar system. The Sumerians, this would constitute the first time in history that the Sumerians drew the sun like that. And it's not as though the Sumerians were like wishy-washy about how they depicted the sun. You got to remember, they worshipped the sun. The sun was Shamash. I mean, the sun appeared in almost every Sumerian relief, and it was depicted either one of two ways. One of which was like a circle with some squiggly lines in it, and very many examples in that. And another one is, especially in later times, towards the Assyrian times, and a little before that, is the solar disk. But we could go through many different ways to show that that solar disk was referring to Shamash, the sun god. We could go into detail, and Heiser goes into much more detail. I don't want to spend too much time on that because it's a radio show, and I'm not really going to be showing you pictures here. But I do want to mention a few things about Nibiru in terms of their texts. Now, nobody could have done this when Sitchin was writing his books in the 70s and 80s, but nowadays we can do a word search in the Sumerian for every instance of the word Nibiru. Every tablet that is known, like millions of these tablets, right? It took 90 years, but what they did was they took every word that's ever been mentioned in every tablet and they cataloged it. Okay? So, again, this is a massive project. The Chicago Assyrian Dictionary, CAD, the Oriental Institute, you can find this online. Okay, so there's maybe, out of all these texts, of all the possible mentions of this word Nibiru, I think it's something like 20 times is the thing mentioned. 20 times, okay? So we can look at every single instance that this word was used. Keep in mind, this was impossible at the time for the common man to do this unless they were like at the university, you know, where these cards were. So Sitchin knew he could get away with lying about what Nibiru was because he knew nobody would look it up or couldn't look it up. But nowadays we can look it up, and there is not a single text that has Nibiru as a planet beyond Pluto. There is not a single text in all those words that connects Nibiru with the Anunnaki. It never says, and the Anunnaki went to Nibiru, or Nibiru and there's just no association with the two. Complete and total lie on the part of Sitchin. The idea that Nibiru is cycling around the solar system every 3,600 years is a total fabrication. There's no other way around it. The guy just made it up. He knew you wouldn't be able to figure it out, so he made it up. In fact, the way that they talk of Nibiru, it's there every year. I mean, it totally destroys Sitchin's thing. What they believe Nibiru was, was around every year. And the reason I'm not being exactly direct in what they believed it was is because there is a little bit of debate about what the Sumerians believed Nibiru was. The reason is because they refer to it pretty much as three different things. I don't want to confuse you, because you're going to think, oh, well, the confusion is because it's a planet from the whatever. But the confusion has nothing to do with it possibly being, it's such insane. What I mean is that almost every instance they call it Jupiter. It's unambiguously Marduk. It's Jupiter. But on one occasion it calls it Mercury. And again, they knew what Mercury was. They knew what Jupiter was, and that's what they were calling Nibiru. But then there's an occasion where it calls it a star. And the way it speaks of it, it seems as if they're talking about a pole star, which, of course, if you know anything about precession, our North Star, the reason it's the North Star is because of the way precession is right now, but it won't always be the North Star. It'll continually change. So Heiser takes the view that it is probably a pole star because of the way they speak of it. And like I said, it's there every year. But I don't want to go into too much detail because it's really just unnecessary. What you need to know is that it has nothing to do with 3,600 years. It has nothing to do with the Anunnaki. It never speaks of it as like a planet that's beyond Pluto. I mean, at the very least, it's what they knew to be Jupiter and what they knew to be Mercury. So it's a complete fabrication on that stuff. And you can look at Heiser's paper on that for much more detailed information about what I just talked about. Okay, so the idea, of course, about Planet X, and this depends on who you're hearing it from, Marshall Masters says that by 2012, we're going to see two suns in the sky. So he thinks this is a binary star system. Now, one of the things that the guy always says is that NASA believes 80% of the universe is binary stars. And that's true. I mean, that's like the one true thing the guy says is, yeah, there are mostly binary star systems. Binary star systems are essentially two suns per solar system. Sometimes they have their own planets for each star and stuff like that, but there's lots of different variations. And yeah, we are unique if we're not, but not that unique. Like 20% don't have binary star systems. So it's not like we're really unique, but yeah, we are a little unique if we don't have a binary star. And NASA and other scientists, they still haven't discounted the possibility that we're part of a binary star system. But the difference between everybody else and Marshall Masters, or anybody else that kind of believes this way, is that when they speak of us possibly being a binary star system, they're speaking of it being anywhere from 25,000 to 95,000 AU, that's Earth to Sun distances, away from us. I mean, that's an amazingly far distance from us. And of course, it would have to be that far distance for it to go unnoticed. And that brings me to my next point. And we'll talk about Nemesis more and what that means here in a second. My next point is, I talked a lot about this in the last episode, so I will only briefly touch on it, is lack of gravitational effects. If there was a super massive, or even just kind of massive object even approaching our solar system, we would know it. I have a little bit more information about what I was talking about last time. With amateur astronomers and everybody else, they know the planets are where they're supposed to be because of the consistency of our solar system. Everything's doing what it's supposed to be doing in our solar system. That's why astronomy programs are perfectly accurate. That's why when NASA sends a satellite to intercept a comet and all this other stuff that it does, it seems like impossible. It all works because everything's doing what it's supposed to be doing, essentially. Planets are where they're supposed to be based on their mass and other, laws of planetary motion and stuff like that. Now, I talked a little bit about the history of that before, and I'll mention it briefly. But if a object comes in our solar system, it will mess that up. Even if it messed it up just a little bit, it would be immediately noticeable, not just to NASA. We don't have to wait on NASA for this. This would be something that every amateur astronomer in the field would tell you about the next day. if all of a sudden the astronomy programs are off, or, you know, they're always looking for something called occultations that passes in front of an object. Like, you can study a star or something else that's really far away a lot better if you wait till a planet gets in front of it, and then as those moments when it starts to appear out from the backside of a planet, you can actually see stuff that you wouldn't normally have seen. So it's a really important part, a thing that amateur astronomers do. And none of that would, of course, work if the planets weren't where they're supposed to be when they're supposed to be. So the minute that they're not where they're supposed to be, everybody would know it. And the minute that an object comes even kind of close to us, that won't be that way. Mike Brown, the guy who was instrumental in demoting Pluto as a planet, said the following: there are very good limits as to what you can hide at what distances in the solar system and not detect their gravity. You could put a Mars a few hundred AU, which is 10 times more distant than Neptune, 10 times bigger than our solar system, further out, and everything would be fine. That's the size of Mars. You could put Jupiter a few thousand AU, that's 1,000 times the distance of Neptune, and again, you're safe. There might even be things out there that we might find. He goes on to say, it's not impossible that the sun has a brown dwarf companion, but to be hidden from us, it would have to be much, much further out than the Kuiper belt, maybe like 100 times further. And at that distance, its effects on the Earth are pretty much zero. Now, a brown dwarf star in our near solar system, there have been models of this, I think I talked about it last time, of this thing coming in our solar system, what it would do to our planets and stuff like that. It's amazing. We wouldn't be saying stuff like, oh, you know, the sun is getting hotter. We would be saying, hey, our calendars no longer work and everything is going crazy. And that's before it even gets that close to us. So I just want to really, really reiterate that this thing would be extremely noticeable, even if you take all the theory. Anybody that has a Planet X theory has to do this thing first. They have to explain why nobody can see it, why you can't hear, smell, taste, touch, why it's invisible to every known possible thing. And so they come up with all kinds of theories, some of which we'll talk about in a minute. But the main thing they can't and don't have an answer for is why can't we feel it? Because the gravity is the thing that would do it, even if you gave them that it was somehow invisible. And of course, if this thing is as big as it's supposed to be, it would be occulting stars behind it, even if it was black and had no light, which is altogether impossible anyway. But especially if it's a brown or red dwarf, yeah, they're dim at certain distances, but when they're close, they're like a star. So yeah, if this thing is close, not only would it be bright, but I'll even give them, okay, let's just say it's not bright for some ridiculous reason, it would still be blocking out a whole bunch of stars if it was close. And so some people say it's coming from the south. You see, all the planets are going around the ecliptic, okay, which the ecliptic is a flat, if you just, the middle of the sun is the ecliptic, and all our planets are basically not exactly right on the ecliptic. They're actually in various, but they're basically more or less on the same plane orbiting the sun, except for Pluto, which has a slightly irregular orbit. And so they say, no, it's not on the ecliptic. It's going, in a sense, in an up-down way, a perpendicular to the ecliptic. And so it's going to come at us from the South Pole, and we'll talk about the South Pole telescope. Even if it was doing that, it's not going to escape the gravity effects of the sun. I mean, that's like an elementary point of Newton's laws of gravity, that a sphere will act, gravitationally act in all its directions, not just on the ecliptic. The reason why things, orbit in the ecliptic ultimately is because they orbit to each other's center of their mass. It's such a common thing that even if you look at galaxies, you'll notice that they are all in disks. Even after, of course, all this time, they are orbiting in a disk-like shape. You don't see a big ball of a galaxy, they're in a disk. That's because that's how things do that. when you say, oh, well, this thing is coming in an up-down way, and that's why you can't see it, number one, it would still gravitationally mess with everything, and you'd still be able to see it. This is the same way that a lot of comets come in from that area. There's a cloud of comets around us. They call it Oort cloud. And then there's another band of comets called the Kuiper belt. The Kuiper belt's like about a light year past the sun or something like that. And it's basically a big asteroid belt on the outer rim of our solar system. It's orbiting the ecliptic. But then the Oort cloud is just basically like that, a big cloud around our solar system kind of thing. They will get kicked in, and when they get kicked in, they come at us in all kinds of weird orbits and stuff like that. Or weird trajectories, I guess you could say. So it's not like, you know, we don't know anything about those just because they're coming in from odd trajectories or whatnot. So not only is that wrong, the idea that it's coming from the south is just a way for them to say, oh, well, here's one reason you can't see it. But I think, as we talked about last time, that makes no sense either, because spherical geometry is such that if you're standing on, for example, the North Pole, you're able to see half of the night sky. It's not exactly perfect, but if you're standing other places on the Earth, if you have a flat terrain, you can, throughout the course of the entire night, you'll be able to see half of the night sky, more or less, give or take. So from the equator, over the course of a year, you're going to be able to see the entire south sky. But anywhere below the equator, of course, you're going to be able to see more and more and more. And there are lots of examples of this. I mean, it's well known. The Gemini telescopes, that's what they boast about, that they see the entire night sky collectively. There's two telescopes. One is like in Arizona or something, and one's in Chile. And because they're on both the north and south hemispheres, they can image the entire sky together collectively. And so you don't hide anything by putting it on the South Pole. The South Pole, of course, is the South Pole telescope is the big thing. You know, the government's trying to hide it from you. But if the government's trying to hide it from you, they have a really funny way of showing it, because they built this massive, expensive telescope that is completely worthless for imaging dwarf stars or planets or stars or anything else. They built this great, extremely expensive telescope that doesn't even operate on infrared. It operates on, if it imaged a planet, it doesn't do planets. It doesn't do dwarf stars. We have dwarf star telescopes that are way unbelievably good, like WISE and IRAS, which we're talking about in a minute. But the South Pole conspiracy is ridiculous. That telescope operates on millimeter and sub-millimeter and microwave bands. These are huge bands you could measure on a ruler, and they are non-visible. The goal of the South Pole telescope is to image galaxies in the cosmic background radiation. It's to image things that are so distant. It's specifically tuned to do things that, by them being able to do those things, they make it impossible for them to be good at searching for Planet X. So it requires an ignorance of what is actually there in order to say, it's all about Planet X at the South Pole telescope. It's definitely not about Planet X at the South Pole telescope.